Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. Now we discuss about the energy stored in capacitors. Energy stored in capacitors, applications of the capacitors. See here, energy stored in the capacitor. Consider this is the capacitor. It consists two conducting plates. One conducting plate have a positive, another one is negative charges. So here, small amount of the charge is small amount is delta q dash. Small amount of the charge is traveling from negative conductor to the positive conductor when you apply the external electric field. When you apply the external electric field. So in normally there is a positive and negative charge in the conductor. The field lines are traveling from positive terminal of the conductor to the negative terminal of the conductor. Okay, negative terminal or positive terminal, that means both are in the capacitors only. Okay, so here the field lines direction from positive terminal to negative terminal. That's all. So here this small amount of charge is traveling from the negative terminal to positive terminal. That means work is done on this capacitor. Work is done on the capacitor. Okay. So here small amount of charge is moving from negative to positive. So that's why here small amount of work is done. This small amount of work is delta W. Delta W. That is equal to V into delta Q dash. So this V means V dash here. So V dash is the potential difference between these two conducting plates. So we know that capacitance C is equal to Q by V. By using this equation, V is equal to Q dash divided by C. Delta W, that is equal to Q dash divided by C into delta Q. So this is the first statement. For a large amount of charge transfer, the work done will be large amount of charge. W is equal to Q square by 2C. W is equal to Q square by 2C. By using this equation, we have to take the integration process. Integration process. Integral Q dash delta Q. Q dash converts into the Q dash square divided by C. So that means Q square by C. Q dash is a small amount of charge, but Q is the large amount of charge. So W is equal to Q square divided by 2C. W is equal to Q square divided by 2C. That is equal to half CV square. CV square. So we know that C is equal to Q by V. Q is equal to CV. Substitute the CV in the place of Q. That gives C square V square. C square C cancel. Half CV square is the remainder. So again here CV into V. CV that is equal to QV or QV. So work that is equal to half Q. So this is the another statement in this energy stored in the capacitor. Okay. Next, energy stored in the capacitor, that is here work is done on the charge that gives Q square by 2C. This work is stored in capacitor like a energy, that is capital U, that is equal to Q square divided by 2C. Q square divided by 2C. So by using the surface charge density, sigma is equal to Q by capital A. Capital A means area, charge divided by area. So that means Q is equal to sigma into Q. Q is equal to sigma into A. Q is equal to sigma into A. Substitute the sigma into A at the place of Q. That gives A sigma whole square divided by 2C. A sigma whole square into 2C. So at the place of C, you have to substitute the capacitance of a parallel plate capacitor. That is C is equal to epsilon naught A by D. This is the denominator term. So that's why multiply this value D divided by epsilon naught A. So here A square into sigma square divided by 2 into D divided by epsilon naught A. A square A cancel. So remaining term is half epsilon naught E square into A into D. So here capital A is the area, D is the distance. So this gives volume. So energy density is energy stored per unit volume. So what is the meaning of energy density? Energy stored per unit volume. So here U is equal to half epsilon naught E square. Half epsilon naught E square, where AD is the volume of the region between the plates of capacitor. So that volume is unit. Unit means 1. So this is the energy stored in the capacitor. Next, applications of the capacitor. First one, powertrains. So in this one, engine control devices, engine cooling fans, DC or AC converters, or here DC or AC converters, transmission control devices, pump control devices. Next, interior, car GPS systems, car audio systems, air conditioning, body control units, instrument clusters, door locks, power seats, chassis and safety devices, power steering, airbag control, ceramics, radar systems, brake control devices, ABS, traction control. Next, exterior, lights, power wipers, power sliding doors, grease shutters. So these are the applications of the capacitors. So next, effect of dielectrics in capacitors. So consider these two diagrams. So here in this diagram, this is the plate, conducting plate by the positive charge. This is also plate conducting by the negative charge. Both are separated small d distance. This total arrangement connected with a battery. In this diagram, there is no battery connection, but dielectric element is inserted in between these two plates. So what happened? Dielectrics are introduced in the capacitors. Okay. At the starting condition, there is no any insertion of the dielectrics in between the plates. Battery connection is on. Here, electric field is generated, that is E naught. Electric field is generated, that is equal to E naught. Capacitance also generated, that is C naught. C naught is equal to Q naught divided by V naught. C naught is equal to Q naught divided by V naught. When you insert the dielectrics, you should mention the permeability. You should mention the permeability. Particularly that is relative permeability. Permeability, it is the ratio of the magnetic. So this is the electronics. So that's why we are using only electric flux strength divided by electric field strength. Permittivity, permeability. Permeability, it is the ratio of electric flux strength divided by magnetic field strength. That is the ratio of permeability. So relative permeability, that is epsilon r, that is epsilon r. Relative permeability. That is the ratio of permeability of the material and the permeability of the free space. Permeability of the free space. When you enter the dielectrics in the place of two conducting plates of the capacitors, all the values without connection of the battery, that gives capacitance C is equal to C naught divided by epsilon r. Voltage V is equal to V naught divided by epsilon r. Electric field E is equal to E naught divided by epsilon r. When you apply the battery to these plates in the presence of dielectric, this E naught and V naught and Q naught, C naught values are converts into multiplication with epsilon r. That means E is equal to E naught into epsilon r. V is equal to V naught into epsilon r. C is equal to C naught into epsilon r. When you apply the battery in the presence of dielectric, epsilon r is multiplied with starting value, either it is electric field, capacitance, or charge. There is no any application of the battery. This is divides that before value. When you apply the battery, this relative permeability multiply the starting value. Without application of this value divides that before value. So this is the effect of dielectrics in capacitors. So thanks for watching this video. For more videos, visit www.expertisoracademy.com. Thanks again.